Alright, so here's the third video we're going to do determining where a function's concave up, concave down, and we're also going to find the inflection points. Alright, so to test for concavity, f is a function whose second derivative exists on an open interval I. If the second derivative is greater than 0, or the second derivative is positive, for all x in the interval I, then the graph of f is concave upward in that interval. And if f double prime is less than 0, or the second derivative is negative for all x in I, then the graph of f is concave downward in that interval. So what we need to do is we need to find the second derivative, set it equal to 0, and solve. Alright, so let's look at our problem. Alright, so determine the intervals where the graph of the function is concave upward or concave downward, and we're going to find inflection points. Alright, so let's find the second derivative. So first we need to find the first derivative. So to find the first derivative, I've got to use the quotient rule. So it's the derivative of the numerator, which is 2x, times the denominator, minus the derivative of the denominator, which is 2x, times the numerator. And that's all over the denominator squared. And so what we'll do here is we'll distribute the 2x, we'll distribute. So f prime of x is equal to, let's see, 2x cubed minus 8x minus 2x cubed minus 2x over x squared minus 4 squared. So f prime of x, well, those cancel out, so I'm left with negative 10x over x squared minus 4 squared. Alright, so there's the first derivative. Now to find the second derivative. Alright, so once again, we have the quotient rule. So it's the derivative of the numerator times the denominator minus the derivative of the denominator. Now here I'm going to have to use the chain rule to take the denominator. So that's 2 times x squared minus 4, subtract 1, that gives me a 1, times the derivative of what's in the parentheses. So times 2x. And then times the numerator, so times negative 10x. And that's all over the denominator squared. And so I get f double prime of x. And I'm not going to go through all the steps here, save a little time. This would be to the fourth, and this would cancel and leave me an x cubed. This cancels out, and this cancels and leaves me, I'm sorry, not a cubed, leaves me to the first power. And then you would just distribute, combine like terms. And after we do that, we would end up with 10 times 3x squared plus 4 over x squared minus 4 cubed. Alright, so there's the second derivative. Now we need to set the second derivative equal to 0 and solve for x. But if you look at this, you see this numerator here, it's never going to be negative. Because if we took the numerator, set it equal to 0, we would get x squared as negative 4 over 3. And so x would be plus or minus 2I over square root of 3. See how we get an imaginary solution? So the second derivative is never going to be 0. But if you notice the denominator, the second derivative is undefined at plus or minus 2. Because if we take the second derivative I'm sorry, if we take the denominator, set it equal to 0, we get x equals plus or minus 2. So we're going to use those to test for concavity. Okay, so when you're testing for concavity, find where it's 0. Use those values to put on the number line that we're fixing to do, and also use the points where it's undefined. Okay, all right, so we're going to use plus or minus 2. So I'm going to erase all this and write the second derivative. I'm going to write the second derivative and where it's undefined up at the top. So let me erase all this. Alright, so I've got everything rewritten. Now let's draw our number line and plot the -2 and +2 on there. And that breaks it up into 3 regions. So now I need to choose a number from each region. So x equal -3, x equals 0, and x equal 3. See, we're using test points to see if it's positive or negative in each region. Alright, so now I need to evaluate the second derivative at -3. So f double prime of -3, okay, so I plug the -3 in. Now, I don't care what the exact value is. All I want to know is the second derivative positive or negative when x is -3. Alright, so we don't really need to plug the -3 in here to the numerator, because no matter what value we plug in, it's always going to be positive. See, this is a +10, and whatever number I plug in for x, I'm squaring it, and that's going to be positive. So I'm going to have a positive number plus +4, so that's always going to be positive. So I'm going to have a positive over, so now I need to plug the -3 in, so that's going to be 9 minus 4, which is positive, raised to the third is positive, so positive over a positive, that's greater than 0. Okay, so that tells me in this region, since I got a positive answer, that it's concave upward. Alright, now let's plug the 0 in. So f double prime of 0, okay, so when I plug the 0 in, we know the numerator's positive, so that's going to be 0 minus 4, that's -4. -4 to the third is negative, so I have a positive over a negative, which is negative, so this is less than 0. So that means in this interval, it's concave downward. And now we plug in the 3, so f double prime of 3. When I plug that in, I'm going to get a positive, and so since this was positive, it's concave upward on this interval. So we have concave upward on this interval, -infinity to -2, and it's concave upward from 2 to infinity, and then it's concave downward on this interval from -2 to 2. Alright, so now we found the concavity, the intervals where it's concave up, concave down. Now let's find the inflection points. So let me erase this. So inflection points, that's where it changes concavity. You see how it changes from concave up to concave down at x equal -2? Okay. Well, it changes concavity, but there's no inflection point, because if we plug the -2 into the original function, it's undefined because we get a 0 in the denominator. So although it changes concavity, it's not an inflection point because the function is undefined at -2. And the same thing for +2. It changes concavity, but 2 makes the function undefined. So there's no inflection points. So no inflection points. Okay, because -2 and 2 is not in the domain of our function. Alright, so hopefully this helped. I have 2 other videos on this, so you might want to watch those too. They're a little bit different than this problem. Hopefully it helped. And don't forget to like and subscribe. Alright, thanks.